helpers for computing deltas. Methods: difflib.endif a b line junk is equal to none, char junk is equal to is char junk. Compare a and b list of strings. Return a defer style delta, a generator generating the delta lines. Optional keyword parameters: line junk and char junk are filtering functions or none. Line junk, a function that accepts a single string argument and returns true if the string is junk or false if not. The default is none. There is also a module level function is line junk, which filters out lines without visible characters except for at most one pound character hash. However, the underlying sequence matcher class does a dynamic analysis of which lines are so frequent as to constitute noise, and this usually works better than using this function. Charjunk, a function that accepts a character, a string of length 1, and returns if the character is junk or false if not. The default is module level function is character junk, which filters out white space characters, a blank or tab. It's a bad idea to include new line in this. Diff and diff 1, 2, 3. Split lines, dot split lines, keep ends is equal to true, comma, or 3 emu. Split lines keep ends is equal to true. Print blank line dot join diff and is equal to this. Let's do a practical. And diff example. Difflib import start and diff examples and diff print. So 1 at 1 there is no match, and then ORE and then 2 is matched, no, 2 3, and then 3 tree em 1 question mark is ORE question mark is 2 3 question mark hyphen plus 3 plus emu. Okay. difflib.restore sequence comma which return one of the two sequences that generated a delta. Given a sequence produced by defer.compare or ndif, extract lines originating from file 1 or 2 parameter which stripping off line prefixes. Diff is equal to ndif 1 2 3 this, and diff is equal to list diff materialize the generated deltas into a list. Print join restore diff 1 and is equal to this 1 2 3. Print join restore diff 2. Okay. And print this. Let's comment it out. difflib.unified underscore diff a comma b from file to file from file date to file date n is equal to 3 line term is equal to new line. Compare a and b list of strings. Return a delta, a generator generating the delta lines in unified diff format. Unified diffs are a compact way of showing just the lines that have changed plus a few lines of context. The changes are shown in an inline style instead of separate before after blocks. The number of context lines is set by n, which defaults to 3. By default, the diff control lines, those with hyphen 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 plus or at the rate are created with a trailing new line. This is helpful so that inputs created from io.io base.read lines result in diffs that are suitable for use with io.io base.write lines, since both the inputs and outputs have trailing in new lines. For inputs that do not have trailing new lines, set the line term argument to blank so that the output will be uniformly new line free. The unified diff format normally has a header for file names and modification times. Any or all of these may be specified using strings for from file to file, from file date to file date. The modification times are normally expressed in the ISO 8601 format. If not specified, the strings defaults to blanks. S1 is equal to bacon backslash n, x is equal to this system.stdout write lines unified.diff underscore diff s1 s2 from file before.py to file after.py. Let's run it. Unified diff example. Unified diff underscore example. Again, import from difflib import star and import sys right. Let's remove this one and run it. So before minus to before plus at the rate -1 4 +1 4 at the rate bacon x ham plus python plus eggy plus hamster guido match. See a command line interface to difflib for a more detailed example. Difflib diff bytes defunc comma a comma b from file to file from file date to file date n is equal to 3 line term is equal to b backslash n. Compare a b list of bytes objects using defunc yield a sequence of delta lines, also bytes in the format returned by defunc. Defunc must be a callable, typically either unified underscore diff or context underscore diff. Allows you to compare data with unknown or inconsistent encoding. All inputs except n must be bytes object, not str. Works by losslessly converting all inputs except n to str and calling defunc ab from file to file from file date to file date and line term. The output of defunc is then converted back to bytes, so that the delta lines that you receive have the same unknown or inconsistent encoding as A and B. Difflib dot is line chunk line. Return true if for ignoring lines. The line is ignorable if line is blank or contains a single hash. Otherwise, if it is not ignorable, used as a default for parameter line chunk in and diff in older versions. Difflib dot is character chunk character. Return true if for ignorable characters. The character ch is ignorable if ch is a space or tab. Otherwise, it is not ignorable, used as a default for parameter char chunk in NDIF. See also pattern matching Gestalt approach. Discussion of a similar algorithm by John W. Radcliffe and D. E. Metzena. This was published in Dr. Dobbs Journal in July 1988. Sequence matcher objects. The sequence matcher class has this constructor. Class difflib dot this sequence matcher is junk is equal to none, a is equal to blank, b is equal to blank, auto junk is equal to true. Optional argument is junk must be none. The default or one argument function that takes sequence element and returns true if and only if the element is junk and should be ignored. Passing none for is junk is equivalent to passing lambda x false. Lambda x false, in other words, no elements are ignored. For example, pass lambda x in t. Lambda x in t. Lambda x in t. Print result upon backslash t banana backslash t cat false. False. For example, this will return true, true, and backslash t will also return true. Okay. If you are comparing lines as sequences of characters and don't want to sync up on blanks or hard tabs, the optional arguments a and b are sequences to be compared. Both default to empty string. The elements of both sequences must be hashable. The optional argument autojunk can be used to disable the automatic junk heuristic. The autojunk parameter. Sequence matcher object get three data attributes. B junk is the set of elements of B for which is junk is true. B popular is the set of non-junk elements considered popular by heuristic if it is not disabled. B to J is a dict mapping the remaining elements of B to list of positions where they occur. All three are reset whenever B is reset with set sequence 2. Sequence matcher objects have the following methods. Set sequence AB. Set the two sequences to be compared. Sequence matcher computes and catches detailed information about the second sequence. So if you want to compare one sequence object against many sequences, use set sequence 2 to set the commonly used sequence once and call set underscore sequence 1 repeatedly once for each of the other sequences. Set underscore sequence 1. Set the first sequence to be compared. The second sequence to be compared is not changed. Set underscore sequence 2. Set the second sequence to be compared. The first sequence to be compared is not changed. Find longest match. AL 0. ALO is equal to 0. AHI is equal to none. BLO is equal to 0. BHI is equal to none. Find longest matching block in A, ALO, AHI and B, BLO, BHI. If is junk was omitted or none, find longest match returns I, J, K such that A, I colon I plus K is equal to B, J colon J plus K, where ALO less than equal to I less than equal to I plus K less than equal to AHI and BLO less than equal to J less than equal to J plus K less than equal to BHI. For all I, J, K meeting those conditions, the conditional conditions K greater than equal to K I less than equal to I, and if I equal to I, j is less than equal to j are also met. In other words, of all maximal matching blocks, return one that starts earlier in A, and of all those maximum matching blocks that starts earlier in A, return the one that starts earliest in B. S equal to sequence matcher non A B C D A B C D A B C D. S dot longest. S dot find longest. Sequence matcher from difflib import star print if is junk was provided. First, the longest matching block is determined as above, but with the additional restriction that no junk element appears in the block, then that block is extended as far as possible by matching only junk elements on both sides. So the resulting block never matches on junk except as identical junk happens to be adjacent to an insert interesting match. Here is the same example as before, but considering blanks to be junk that prevents ABCD from matching the ABCD at the tail end of the second sequence directly. Instead, only ABCD can match and matches the leftmost ABCD in the second sequence. S is equal to, let's do the S is equal to sequence matcher lambda x. X is equal to this, x is equal to this, comma ABCD ABCD ABCD. S dot find longest match 0 to 5. Let's see the one. B is equal to 0, size is equal to 4. If no blocks matches, this returns ALO BLO 0. This method returns a named tuple match AB size. Get matching blocks. Return list of triples describing non-overlapping matching subsequences. Each triple is of the form IJN and means that A of I plus N and B is JJ plus 1. The triples are monotonically increasing in IJ. The last triple is a dummy and has the value length A comma length B 0. It is the only triple with n is equal to 0 if IJN and IJN are adjacent triples in the list, and the second is not the last triple in the list, then I plus n less than I or j plus n less than j. In other words, adjacent triples always describe non-adjacent equivalent blocks like this. Print this. If I print match A0 B0 2, A is equal to 0, B is equal to 0, size is equal to 2, match A is equal to 3 0 1 3, B is equal to 2, B is equal to 2, and size is equal to 2. Okay, CD CD. And third, HA is equal to 5 0 1 2 3 4 5, B is equal to 4 0 1 2 3 4, size is equal to 0. Okay, get underscore OP codes. Return list of 5 tuples describing how to turn A and A into B. Each tuple is of the form tag I1 I2 J1 J2. The first tuple has I1 is equal to J1 is equal to 0 and remaining tuple have I1 equal to I2 from the preceding tuple, and likewise J1 equal to previous J2. Value meaning: replace, delete, insert, equal. A I1 I2 should be replaced by B J1 J2. Delete. A I1 I2 should be deleted. Note that J1 is equal to J2 in this case. Insert. B J1 J2 should be inserted at the A I1 I1. Note that I1 is equal to I2 in this case. Equal. A I2 I2 I1 I2 is equal to B J1 J2. The subsequences are equal. For example, Q A B X D A B B C D F. S is equal to sequence mature non A B. For tag, comma I1 I2 J1 J2 sequence dot get S dot get codes. Print. Print colon 7 A tag I1 I2 J1 J2 exclude A I1 I2 B J1 J2. Is a list. Q. Delete Q to this equal AB to AB. Replace X to Y equal CD CD. Insert blank to F. Okay. Get underscore grouped underscore OP codes n is equal to 3. Return a generator of groups with up to n lines of context, starting with the groups returned by get opcodes. This method splits out smaller change clusters and eliminates intervening ranges which have no changes. The groups are returned in the same format as get opcodes. Ratio: return a measure of the sequence's similarity as a float in the range 0 1, where t is the total number of elements in both sequences and m is the number of matches. This is 2.0 multiplied by m by t. Note that this is a 1.0 if the sequences are identical and 0.0 if they have nothing in common. This is expensive to compute if get matching blocks or get opcodes has not already been called, in which case you may want to try quick ratio or real quick ratio first to get an upper bound. Caution: the result of ratio call may depend on the order of arguments. For instance, print order of ratio, comma sequencer diet type ratio. Print 0.25 and this. Quick ratio: return an upper bound on ratio relatively quickly. Real quick ratio: return an upper bound on ratio very quickly. The three methods that return the ratio of matching to total characters can give different results due to differing levels of approximation. Although quick ratio and real quick ratio are always at least as large as ratio. Print as dot ratio, as dot ratio, as dot quick ratio. Print as dot quick ratio, as dot real quick. If I run it, 0.75, 0.75, 1.0.